this is from the 2022 HSC paper. Now, I know you guys are like, oh, why are we doing the HSC? We've only just started year 11. That's because
Wait, so where do you find the question?
it's in the enzymes module. So the reason why I'm giving us a HSC question without teaching you any HSC content, not because I'm crazy, but it's because if you read this question carefully, you actually realize it doesn't actually, you don't need to know any like prerequisite knowledge, right? What this is basically a skills question with like a fancy coat of paint on it, right? But the concepts we're going to cover here will be the same concepts that you're going to use to fill out your table, right? So yesterday we started the table on our enzyme pracs, and we looked at like variables and then like validity, reliability, accuracy. So I'm going to do that again today with the context of writing an appropriate method, right? Because the main idea from this question is just how can I write an appropriate method, right? So I'm just going to I'm going to go through considerations we need to have when we write a method. And then by doing that, we'll also learn and refamiliarize ourselves with like terms in science, right? So I'm just going to read the question. Jellybush honey has been used by Aboriginal peoples to treat cuts, sores, and burns. Recent studies have shown that jellybush honey has a very high level of methylglyoxal, which is known to help fight infection. A scientist wants to test the effectiveness of jellybush honey using agar plates. Design a safe procedure that a scientist could use in a lab to investigate the effectiveness of jellybush honey as a pharmaceutical to inhibit bacterial growth. All right, cool. So before we write a method, we've got to plan out what we're going to say. And the idea here is there's an experiment, and we're just trying to figure out how effective this jellybush honey thing is at fighting off bacterial infection. Now, we've all worked with agar plates last year, right? Yep, those yellow plates, and then like you swab them with like your phone or like the door, and then we chuck them in an incubator, and like 3 weeks later, it's like absolutely disgusting, right? Yeah, cool. So those are agar plates. Agar plates is just a medium to grow bacteria, right? Because agar is just some kind of jelly / food. All right, so when we plan our investigation, we want to make sure we have our 3 variables, right? So our independent, dependent, and control variable. Just to recap quickly, what does the independent variable, like what is it? Yeah, the thing we change, right? So we're changing, what's the dependent variable? Measuring. And what's the control variable? Stuff we keep the same. And I'm going to put one more. What's a control group? How's that different from the yes, Rebev?
We didn't know no change to it.
Yep. So a group where you apply no intervention. And by intervention, I mean applying the independent variable, right? So we literally just do nothing to the control group, right? So we have these things that we need to worry about. Let's figure out what they are. Yes?
When you're like writing out this question in your blinds, do you literally just list your variables? Like that?
In an exam, I might put this on the side because I would actually write the method.
Oh, okay.
But this is just like the planning before.
Okay.
Yeah. Yes?
Can the independent variable be
In this experiment,
in like if it did state the time, would that be the independent variable?
yeah, if that's what you were changing, then sure, it can be. So for this prac, can someone tell me what are we going to change to do this prac well? Yes, Ali? Not quite, because this is where we've got to change something in this prac, right? Yes?
Maybe like the amount of bush honey?
Yeah. Okay. So because we're trying to figure out if this has any effectiveness on killing bacteria, we're probably going to have some plates that have no jellybush honey and some plates that maybe have increasing amounts or have jellybush honey, and we're going to compare the difference between the two and see if there's been some bacterial growth, right? So the change, my independent variable is going to be presence of jellybush honey. I'm just going to write JBH because I'm lazy. What are we going to be measuring in this prac?
Bacteria.
Yeah, bacterial growth. Yeah. And what are some things that we can keep the same to make it a fair test? Yes.
Is that the same bacteria from like the same place?
Okay, so you're swabbing it with the same bacteria. Yeah, sure. What are some other things we should keep the same besides swabbing it with the same bacteria? Amount of what?
Of bacteria.
That's very hard to regulate. Yeah, I don't know how I would manage that actually.
Like the same place.
Yeah. I'm gonna lump that in the same location. What's something else about this prac that we can keep the same? Yes, Taylor.
The shape of the honey when you put it on the plate.
Oh, so apply the honey the same way.
Could the dependent variable be like the zone of inhibition, and then you do different amounts of honey?
Yeah. You could measure that too. There's many ways to go about this question. Yeah. Yes.
Like how long
Yep. So how long we're incubating the plates for? Right. So make sure our incubation period is roughly or is the same for all the plates. One more thing I might add here is incubation temperature. Right, and if I were to have a control group where I do no intervention, what's that going to look like? Yes, Aiden?
Like the plate with bacteria and no jellybush honey.
Those would be those would fall under our independent variable groups. If there was a plate with bacteria and no JBH, a control group is literally no intervention, so we do nothing to it at all. So it would just be a plain plate of agar. Yeah.
Is there no bacteria?
Yeah.
Okay.
Right. The reason why we just have a plain plate of agar that we do nothing to is because if we don't have a control group, we can't know if the agar itself was already contaminated before we did the experiment. Right. So that's why you set aside one and literally do nothing to it. And if your control group has some growth on it, even though you've never exposed it to anything, then your entire experiment is screwed, right? So that's our variables, right? So just a recap of what we're going to do. We're going to have we're going to have, let's say, a few plates. We're going to put varying amounts of jellybush honey, right? So maybe one plate we have nothing, and then we'll maybe increase the amount of jellybush honey slowly with the plates. We're going to incubate them for a period of time, and then hopefully, if jellybush honey is effective, the plates that we applied it to will have less bacterial growth, right? And our control group, which we're going to set aside, is just a plate that we haven't done anything to at all, right? So that's our outlook of the experiment. Now, 3 more things we have to consider in this prac is validity, reliability, and accuracy. I'm trying to figure out where to write that around. All right, validity. All right. Let's define the terms first, and then I'll explain how it applies to this experiment. Can someone tell me what validity is? What is validity? Yes, Hannah? Yeah, fair test, right? So it's a lot of things. I like to say fair test because it's simple. The technical term for it is how appropriate a method is to the experiment. But how you judge how appropriate it is by seeing whether or not it's a fair test. I'm just going to write fair test because it's simpler. Right, and in this experiment, how are we considering the validity of this thing here? Like what components here give my experiment validity? Yeah?
Keeping the controlled variables constant.
Yeah, right. So basically, I answer how valid my prac is by having these variables, right? By making sure I'm only changing one thing, by making sure I have a control group, and by making sure I have all these control variables, right? This all falls under validity, right? So I just want to talk about, when proving the validity of my prac, I want to talk about how I'm doing all these variables well, right? Let's move on to reliability. What is reliability? Yep, how reliable, but you can't use the same word to describe it. That's cheating. Any takers? Yeah? Not quite, very close though. Yeah.
Is it like the amount of times you like repeat the prac and get the same result?
Yeah. Perfect. So it's the consistency of results, right? So consistency is the key term. Now, like obviously, just because you do something over and over again doesn't make it reliable, right? The example I always use is like, sorry, let's say Ari is in my roll call class, and one day he comes to school at 8:40, and I'm like, dude, you're late. And then one day he comes at 8:20, I'm like, oh, you're the first one here. And then the next day he comes at 12 o'clock because he slept in. He's coming to school every day, so he's repeating that, but he's not coming at the same time. So he's not reliable, right? Because he's not consistent. Sorry. Now let's say maybe I'm in Ari's roll call class again, and I see he comes in at 8:35 every day. So he's still late every day, but he comes in at the same time. In that sense, it is reliable because it's consistent, but like he's just late every day, right? Which is still fine, it's reliable. That's just something you take away from your results, right? But I think the key thing here is the consistency of results. So your results should be the same, right? How do we build in reliability into our prac? Yeah. So honestly, it's pretty throwaway. You can just on the last step of your method, just say repeat 5 times. That's it. Yeah, you don't have to do anything. But by doing that, you've considered reliability. This one is the hardest one, I reckon. I find it really hard to define. What is accuracy? Yes, Sunjun?
Precision.
Yes, precision of measurement. An alternate explanation for accuracy is how close your results are to the expected value, right? How close your results are to the expected value. But when assessing accuracy, I like to look at the precision of measurement. Now, what I mean by that is how well we're measuring our dependent variable, right? So if we're measuring our dependent variable really imprecisely, if we're just maybe counting the bacterial growth just with our eyes instead of looking at it more carefully with a microscope, maybe calculating the surface area that's being infected, that all falls under accuracy. So how well you're measuring.
Are you measuring the percentage?
Yeah, I would measure the percentage, or I would count the colonies, one of the two. Yeah. And our final thing, this is a bit throwaway. So this is accuracy. These are our variables. When we're writing a method, NESA also wants us to put in safety considerations. So this is kind of apart from all this stuff. So I'm just going to write it in the corner, right? Plus safety, right?
Do we have to state the risk? Or do we just say what we do to...
You just say what you do to minimize the risks. Yeah.
Can I just take screenshots of this?
Yeah, that's fine. Yeah. All right. So on the board here, I've got the marking criteria for us. Now, I will provide the the sample answer maybe after class. But what I want us to do is just have a look at the criteria and see how basically everything here, what it wants, I have written on the board. We've just got to find a way in our methods to incorporate all of this stuff, or to show our understanding that this stuff needs to be included, right? Because that's what they're looking for. They're looking that we consider all the variables and that we consider safety and have repetition for reliability, right? So every method should have all of this built in. So make sure that when you're writing methods in science, you are detailed enough to include and consider all these things.